All right, so we're going to play around with sine and cosine a little bit. So I drew a line segment here with a new angle, and I'm going to label that angle. That is not a pencil, that's a line. Come on, give me a pencil, please. There we go. So the angle, standard angle, which happens to be the reference angle in quadrant 1, that's going to be theta. And the point here, now what I'm going to tell you about this point is that the sine of this angle theta at that point is equal to 4/5. Right, so the sine of theta here is 4/5. Now, I don't know what theta is. Theta is unknown at the moment. Question, can I find the cosine? Of theta. So COS, cosine of theta, equals what? Well, it turns out I can for a couple of reasons. One, I know this is a unit circle. So I know that this length right there is 1. On this point right here, I know the y value of the point. So if I draw here what it means for y, which is the sine, right? Remember, on the unit circle, the y value is the sine. That's the vertical leg of this right triangle here. So now I can figure out the horizontal leg, which happens to be the cosine. Remember, on the unit circle, the x value is the cosine of the angle. And now that I have a right triangle from this point, I can use the Pythagorean theorem. So again, here, y is this leg of the triangle, x is that leg of the triangle, and x is the same as the cosine of theta on the unit circle. So I can figure out what the cosine of this angle theta is, even though I don't know theta, but because I know the sine, the y value. So Pythagorean theorem says that if you square the lengths of the legs, so x squared plus y squared, that has to equal to the long side squared, 1 squared. Now I happen to know y, so now I know that x squared plus parentheses 4/5 squared equals 1 squared, and I can clean this up. 1 squared, let's do that, that's pretty easy. 4 squared is 16, 5 squared is 25. So I know x squared, oops, plus, not equals, plus 16 over 25 equals 1. Let's subtract the 16 over 25 to the other side. X squared equals 1 minus 16 over 25. So let's see, that would be 25 over 25 for 1. 25 minus 16 on a good day is 9 25ths. And then to get rid of a square, I take the square root. Let's get the color for that. Square root, square root. Now, technically, when we take the square root of a square, we get a plus or a minus. So then I have to decide, do I want the plus here or do I want the minus? And that would depend on which quadrant we're in. I'm in quadrant 1 here, and in quadrant 1, both x and y are positive. So I want the positive version in this case. And then I can clean it up. Square root of 9 is 3. And square root of 25 is 5. So this should be 3/5 for the x value. Does that seem reasonable here on my picture? 3/5 is 6/10. Yeah, that seems reasonable here on my picture. Oh, shit, I wrote some things backwards here, didn't I? I wrote my x's and y's backwards. Oh my gosh. Better straighten that out. Can you see that now? I said, let's see. Oh, 4/5, that should have been the x value here, right? I confused my x and my y. That happens to the best of us. All right, no big deal. I just swap x and y and I got the right answers. So y is the sine, but I actually here 4/5 is 0.8. So I lied in the beginning. Let's straighten that out. So what I actually gave, the 0.8, that was the horizontal distance x. So this is the cosine of theta is what I gave. And so if I start with the cosine, then I'm finding the sine. And then my x's and y's are just backwards here. So we're just going to scribble that out and say y equals. And we're good enough. Good thing I drew a picture to verify my answer here. All right, we're going to do another one of these in just a second. And again, quadrant awareness is going to be important because when we solve some of these equations, we're going to get a plus or a minus, and we have to decide, do we keep the plus or do we keep the minus? It depends on the problem. All right, new similar problem.